Welcome to AI Frontiers. Today, we explore groundbreaking advancements in computational linguistics published on July 15, 2025. Discover how machines are mastering human language, innovations in multimodal learning and reasoning, and their transformative impact on accessibility, healthcare, and education. This presentation delves into the heart of computational linguistics, a field bridging humans and machines. We will examine key themes like multimodal learning, explainability, and multilingual systems, and highlight groundbreaking findings and methodologies. Additionally, we'll feature 3 seminal papers shaping the future of computational linguistics. Computational linguistics blends insights from computer science and linguistics to create systems capable of processing, understanding, and generating human language. This field powers tools like Siri, Google Translate, and chatbots, with applications spanning accessibility, healthcare, education, and global communication. It plays a critical role in advancing human-computer interaction. Multimodal learning combines text, images, and maps to enable richer understanding. Srivastava et al. Introduced MapIQ, a benchmark dataset for diverse map question-answering tasks. Their work evaluates models on cartograms, proportional symbol maps, and more, emphasizing the need for robust AI and real-world data visualization. Explainability and interpretability are central to building trust in AI systems. Sparse autoencoders isolate language-specific features, enhancing transparency in multilingual models. These techniques clarify decision-making processes, promoting ethical and accountable AI systems that align with human expectations. Cross-lingual systems aim to develop models effective across multiple languages. Ahmed et al. Led the ImageClef 2025 challenge with ensemble-based methods, while the Honsha Bridge technique advanced Korean-Chinese translation. These efforts democratize access to advanced AI for underrepresented languages, fostering inclusivity in technology. Among the breakthroughs, Krabs by Li et al. Achieves 98% F1 scores for code dependency analysis. Xie et al. Formalized math problems with 64% high-quality results, and Xie et al.'s KV latent reduces memory usage while maintaining performance. These innovations enhance efficiency, accuracy, and scalability in computational linguistics. Researchers employ common methodologies like prompt engineering, fine-grained evaluations, and continual pre-training. Prompt engineering guides large language model behavior, while fine-grained evaluations uncover nuanced strengths and weaknesses. Continual pre-training updates models without catastrophic forgetting, integrating human expertise with computational power. Krabs, developed by Meng Li et al., uses a syntactic semantic pincer strategy to analyze Python notebooks efficiently. It achieves 98% F1 scores for identifying information flows and 99% for execution dependencies. This breakthrough has practical implications for data science collaboration, transforming notebook reuse and adaptation. MapIQ, introduced by Varun Srivastava et al., is a comprehensive benchmark dataset spanning 3 map types and 6 themes. It evaluates models on visual analytical tasks and modifications, offering insights into handling real-world map complexities. MapIQ sets new standards for benchmarking multimodal systems. EXA-1 4.0, developed by LGAI Research, integrates usability with advanced reasoning capabilities. Available in mid-size, 32 billion parameters, and small size, 1.2 billion parameters, it supports multilingual modes including Spanish, English, and Korean. Publicly accessible, EXA-1 4.0 democratizes cutting-edge AI research. Future directions in computational linguistics include addressing data contamination and evaluation validity, balancing model complexity with computational efficiency, and enhancing transparency and trustworthiness. Expanding inclusivity for underrepresented languages and dialects remains a priority, requiring interdisciplinary collaboration and novel hybrid approaches. This podcast was created using GPT-Quen, QuenMax, Amazon TTS, and Google image generation tools. While content was reviewed by human experts, oversights may exist. References are provided for all summarized works. These tools enable efficient synthesis of complex research narratives, bringing clarity to cutting-edge advancements. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses R14.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by R14.org.